वालेकुम सलाम। बोल बोल बताओ। एग्जैक्टली 8 बजे 9 बजे। चल सही। वो फॉर्मेट नहीं, मुझे स्विच करेंगे तो हो जाएगा, ट्रांसफ़र फ़ौरन हो जाता है। Okay guys, just a second please. Alright. Yes, Iman.
There's a lot of background noise.
There's what?
There's a lot of background noise.
Background noise. Okay. Why? Let me see if my mic is in mic mode. Let me see what is this. It should change, right? I wanted to affect mic mode. Let me see why it's like that. There has to be, I don't know how to do that. There was something that would control the noise. Okay, it's not controlling at all. Alright, Imal, is it very bad or is it like alright?
It's sometimes very bad.
Sometimes very bad. Okay, never mind. So let's start now. Yesterday we basically started with the gas laws, and today we are going to do this. It says a student carries out an experiment to find the relationship between the pressure P and volume of a fixed mass of gas. The table contains 4 of her sets of measurement, right? Use the data in table, suggest the relationship between pressure and volume in this experiment, and show how you reach. If you notice, each time the pressure increases, right? You might see that the volume is decreasing, no? Right? So we're going to say her results show that as the pressure increases, the volume decreases, right? And the other thing is, if you realize this, it's not exactly proportional, so we're going to write, so it shows volume and pressure are inversely proportional. Is it clear? Yeah. Now, then it says state the property of gas apart from the mass that remains constant during the experiment. That has to be the temperature, because when you're comparing pressure and volume, the temperature must stay constant at all times. That's very, very important. Okay. Then it says a lake 5 meter deep, the density of water is this. Calculate the pressure. So pressure is rho GH. The density is 1000. We're going to take it as 9.8 from now on, and this is 5. So could you please help me find the answer to this? Go on, please. 49,000 Pascals. Okay. Is it me who's lagging, or is it Imal who's lagging? You guys can hear me, right? Right? Okay. So then it says a bubble of gas escapes from the mud at the bottom of the lake and rises. Yes. Okay. All right. Yes, sorry, come again. I don't think so. I'm lagging, but I don't know what is happening today. So, you guys, you can hear me fine? I'm lagging. Okay. That's not fair. My internet was working fine. Chalo, never mind. I'm gonna change it to hotspot. Okay. I think it will be fine now. Okay. Yes. Can you hear me correctly now? Hello?
Yes, there's no better.
Now it's better? Okay. So it says, place the tick in each tray of the table to indicate what happens to volume, the mass and the density of gas in bubble. Assume that no gas or water evaporates. So when the object, like the bubble, rises to surface, right? So obviously we need to understand that as like the bubble will go up, the pressure is going to reduce, which means the volume has to increase. Do you guys understand that? Which basically means that the volume would increase, the mass would stay the same because mass doesn't change, and obviously then the density of the bubble would decrease as well. The reason why density will decrease is because density is mass over volume. If the mass is same and volume is increasing, the density should decrease. Okay, got it? Okay, very nice. Anyone who could not understand this, please let me know, please. Right, then going to this one. This question, I told you to do it as homework, and yeah, the same and the same. I just want to do this question. These ones are for homework because they are very similar. I would do this one and obviously the next one as well. It says a helium weather balloon is held at ground level. The volume of balloon is 4800 and the pressure of helium is 98 kilopascals. The balloon is released and rises to height where the volume is now this one. Calculate the new pressure. So whenever you're comparing the same thing with two different conditions, you are going to use P1 V1 equals to P2 V2. The pressure in the start would be 98 and kilopascals multiplied by the volume was 4800 meter cube. The pressure now we need to find, and the volume now is increased to 7200 this. So pressure 2 will be 98 4800 divided by 7200. Can you find the answer, please? Go on.
There's 65.3 pascals. Kilopascals.
65.3 kilopascals. Okay. 65.3 kilopascals. Please do not forget units, very important. Then says suggests why it may be necessary to release the helium from the balloon as it rises even higher. Because if the balloon, like if you don't release it, then obviously it is going to get bigger and bigger, and then the balloon may burst, right? So you can write balloon will swell and may burst. Okay, because volume will keep on increasing. Because volume will keep on increasing. All right, is it clear?
Yes, sir.
Okay, very good. Now, so then let's talk about the next thing, which is basically our states of matter. Okay, so now states of matter are basically pretty simple. So let's look at them quickly. Wait a second, please. Okay, so first of all, we're going to look at the melting. Okay, so melting, whenever a state is changing, so it happens at a fixed temperature that we need to remember. Then, number two, the temperature that it melts at is unique to every material. Then, melting happens when all particles have energy to change from solid to liquid. Okay, then heat energy is supplied to weaken the bonds, or you can write intermolecular forces. All right. Also, the melting point of ice is 0 degrees Celsius. You should remember that. Okay, please write it down. Let me know if you have a question. Now, then we're going to go towards boiling. So, boiling happens at a fixed temperature as well. Okay, the temperature is unique to every material, like water boils at 100, for example, and then it happens throughout the liquid, as all the particles have enough energy to escape. All right. Then heat is supplied to completely overcome the intermolecular forces. The boiling point of water is 100 degrees Celsius. You should know that. Okay. Then evaporation. Evaporation basically happens at any temperature. Only the most energetic molecules leave the surface of the liquid. So it can only happen at the surface, like it cannot happen throughout the whole liquid. Okay, so when the most energetic molecules leave, they end up causing a decrease in average kinetic energy of liquid. All right, this causes cooling. All right, is that clear, everyone? So I'm gonna basically, I'll try to make it a different color because I believe that then it would be easy not to mix up. Let's make it purple. Okay, fine. And then let's pick it up. Color blue. Okay, now you will be able to read it better. Okay, any questions, anybody who could not understand anything, please let me know. Caroline, Hussein, Kazim, Zain, Showis, okay, Nawal, okay, sorry, Emal, and Smiley, and Yusra Zainab. Okay, please write this down. I will just come back in 1 minute. I need some water. Okay. Very nice, very nice. Let's go now to the next thing. So then we need to discuss the factors that affect evaporation in general, right? So the factors that affect evaporation are mainly 4 of them. Number 1 is the temperature, of course. Then number 2, surface area. Number 3, we got wind. And number 4, we got humidity. So these are the 4 factors which may affect the rate of evaporation. So higher temperature means greater evaporation. So in like hot days, your clothes may, just get dry easily, sooner than you think. And then greater surface area means greater rate of evaporation. So you would want your clothes to be spread and not like jumbled up, because then if you spread them, the surface area is more, which means they're gonna get um, say dry quickly. Then obviously, if the wind speed is greater, so greater the wind speed, greater the evaporation is. For humidity, higher levels of humidity reduces rate of evaporation. Now, why am I saying this? Because humidity basically means there's already water content in the surroundings, in the air, and obviously, if you put something wet outside, so there's already so much water content in air, it doesn't need more, so the rate of evaporation decreases. All right. Any questions now? Anything you'd like to ask, please? Let me know.
No, sir.
That's pretty good. All right. Now, so going to the next, if you guys have written it, I want to go to the next page. Okay. Okay. All right. I'll go forward then. So then it says state three factors that determine the rate of evaporation of water. Who's going to tell me that? Any three factors, please? You just need to state.
Humidity, wind, and surface area.
Okay, humidity, temperature, and surface area. Okay, and you can also write the fourth one, which is the wind. All right, wind speed. Anyway, then it says a person climbs out of a swimming pool and stands in open air. Explain why evaporation of water from the surface of the person's body causes the person to feel cold. So the ideal answer to this is that the most energetic molecules leave the surface, causing a reduction in average kinetic energy of body, right? Hence, it causes cooling, right? So because they take energy and leave the body, so obviously the rest of the molecules do not have the same, which causes cooling. All right. Should I go to the next one now? If you guys have written this. All right. Now, so then this question basically is for homework. It's described in terms of molecules when a liquid evaporates. 4 marks, I've already given the points, you gotta write that. And then it's a cloth question, say 2 changes in weather that help the wet clothes to dry more quickly. Obviously, you can write any 2 changes that you can, right? Remember, it's like 2 changes in weather. Weather would depend on 2 things, basically the temperature and the humidity, right? Oh, it could be wind as well. Yeah. All right. Is it clear, everyone? So you can do this as homework. This is pretty easy. Now we're going to go towards thermal specific heat capacity, right? So in specific heat capacity, I just want to tell you that it is basically the amount of heat energy required per unit mass. So this will give you 1 mark. So the definition usually comes at 2 marks, and the second mark will be to change the temperature by 1 degree Celsius or 1 Kelvin. All right, so that would give you the 2 marks. Okay. Specific heat capacity symbol is basically small c, and the formula uses c equals to q over m delta theta. You can use delta t as well. So this is the specific heat capacity. This is the heat energy. This is the mass. And this is the change in temperature. So it could be either in Celsius or Kelvin, doesn't really matter. Now comes the SI units. So the SI units of these are joules per kg per Kelvin or joules per kg per degree Celsius. So you can write that as well. Okay. All right, now.
So its symbol is small c, right?
Yes, small c.
Okay.
Then you have basically, if they just ask you about heat or thermal capacity, let's suppose if they say this, all right, between these two, yes.
So in specific heat capacity, is it like 1 kg or 1 grams?
A kg in an SI unit. Okay. If it's not SI, then obviously it could be 1 gram as well, doesn't matter. So heat.
So the definition, should it be per unit mass or per kg, per 1 kg?
It's per unit mass already means that you're taking a unit of mass. Unit means 1 kg or gram. Okay. Okay, Mal?
Okay, sir.
Then heat and thermal capacity. Basically, the difference between simple heat capacity and specific is just the mass. So in this one, we would write it is the amount of heat energy required. Now we're not going to include the mass, and we're going to write to change the temperature by 1 Kelvin or 1 degree Celsius. So that's this. So then you generally want to write it this way. You want to write it like capital C equals to Q over delta theta. So this has no mass in it. Capital C is the symbol of heat capacity. This is the heat energy. Rest of the things are the same. And change in temperature. So like that. Okay, so the main difference is when you make it specific, it means you're talking about 1 kg of mass or a unit of mass. Now, what does it really represent is given in this question. And when you read this question, it says 1 kg of aluminum requires more thermal energy to raise its temperature by 1 degree than 1 kg of copper. So what does that mean? Which means that basically, I'm just going to write it here. The poorer the conductor is, all right, it will require more heat energy to raise temperature to the same value compared to a good conductor, right? So it means that naturally we should understand that the heat capacity that we're talking about again and again, good conductors will have a smaller value of heat capacity. So basically I'm just going to compare this, like for example we can talk about two things first. So if we talk about water, right, so water, and we're going to talk about copper. So copper is a good conductor, water is basically not so good, right, heat conductor. So the water has a heat capacity of 4200 joules per kg per degree Celsius, right? And if we talk about copper, so copper has a heat capacity of 385 joules per kg per degree Celsius. Now, what does that mean? It means that for water, for 1 degree increase, water requires 4200 joules of energy. Do you guys understand that? Similarly, for 1 degree Celsius of increase in copper, it requires only 385 joules. So that is the reason when you're cooking something, you're heating water in a pan, the pan would heat up quickly, but the water will take time to heat up. Do you understand?
Yes, sir.
Now, keeping that in mind, then let's answer me this. It says a 1 kg of block of aluminum requires more thermal energy to raise its temperature by 1 degree Celsius than 1 kg block of copper requires. Why is this? What do you guys think the answer should be?
B.
Okay. Why can't it be C?
Sir, it's D.
Okay. Why can't it be C then? That's my question.
No, D, sir.
D, if it was D, then shouldn't the statement don't you think the statement is wrong then, because it's talking about um, aluminum taking more thermal energy than copper?
Oh, yeah.
Okay, now the real answer to this is C, neither B nor D. So I'm just going to answer you why. The first one states that aluminum is a better conductor of, that is absolutely wrong, because it is not. If it was, it would have taken less energy to raise its temperature more, right? Aluminum is a poor conductor. Okay, well, this is an ambiguous statement because it is obviously poorer, but the thing is, we are right now talking about why aluminum requires more thermal energy to raise the temperature by 1 degree. So we have to talk in terms of heat capacity, which means that aluminum has higher specific heat capacity than copper. That is the reason why aluminum would want more energy to change the temperature by 1 degree. That completes the whole definition. Understood?
Yes, sir.
So always when you answer this, you always give the answer in terms of the concept they're asking. Do not select an ambiguous answer. Then we're gonna go towards this one, and we're gonna then talk about this graph. Okay. So it says, what is the increase in internal energy of the block? By the way, like when we were doing energy, internal energy is basically heat as well, so don't worry. Of a block of same metal of 0.52 kg when its temperature rises from 40 to 50, right? So we're gonna go on to the this. So at 40 degrees, it is right here, and this should be like 812, and till how much we gonna go? 50. It's somewhat like this. And how much is it? 824, right? Do you guys understand this? Now
Sir,
they
why is it 80?
824, no? Basically every there are 5 divisions between a change of 5, so every box would be 1, right? Don't you think so?
That's the why did you take 80
Oh,
and not
sorry.
50?
Oh, sorry, my bad. You should 50. Sorry. We're gonna go 50. Doesn't really matter, but still. Okay, 815, right? So what you're gonna do is, method 1 is when you use the equations, obviously. You say the change in energy between raising this temperature was 815 minus 812. That's going to be 3 joules, right? Now, heat capacity is given by, specific heat capacity is m delta theta. The C we need to find, the energy we supplied was 3, the mass is 1 kg times the change in temperature was 10 degrees. How do I know? Because it goes from 40 to 50. So heat capacity,
Sir,
yes.
sir, it's 3 kilojoules.
Oh, sorry. 3 kilojoules would mean 3000 then. Okay, sorry. So this would be 300, right? Is it so? Right? Now,
Yeah.
then what you're going to do is you're going to use the same formula and you're going to find the heat energy. Now, this is 300, this is Q. The mass now is 0.25, and the temperature change is 10. So what you get? Yes, please.
750.
Sorry?
C.
750 joules. Okay, so this is a longer method, but I think, in my opinion, you could have also done this. For like 0.25, for 1 kg of mass, you require 3000 joules. Then for 0.25 kg, how much do you require? You can cross multiply. So 0.25 of 3000 is 750. That's method 2. You can use the ratio. Whatever you like, you can do that. Alright, is it clear, everyone?
Yes, sir.
Okay, you can write this down, please. Alhamdulillah. Sorry. Okay, hold on a second. You can write it. I'll be back in like 1 minute. Yes, ma'am. हेलो बेटा तुमने पास पेपर सबमिट करवाने हैं ना अप्रैल से लेकर हमको All right, now let's go forward and let's see what's next. Then in this one, it says an experiment to measure. Okay, this is basically the same thing. This is just the formula they're asking. So this is for your homework. We're gonna go to the next one. And it says equal masses of two different liquids are put into identical beakers. Liquid 1 is heated for 100 seconds, liquid 2 is heated for 200 seconds by heaters of same power. Okay, so we're applying like same power would mean that we are giving liquid 2 greater energy, right? Okay. And then,
Say
yes,
repeat, you're lagging. Could you repeat it, please?
this one?
So I don't know.
Which
Why it
one?
stopped.
Okay, yeah. So I gave
So you
you,
were saying something.
my screen is frozen. Why is this happening? It should not be frozen. Is it okay? Okay. So I'm saying that for this one, it's saying you're applying the same power for them, and one is like heated for 200 seconds, the other is heated for 100 seconds, right? So what you're gonna do is they're saying which statement is correct, okay? So obviously, if you're giving same power heat, like the power of heat is same for both of them, it means that this is taking up more energy. And if this is taking more energy, then obviously the thermal capacity of liquid 1 is less than liquid 2, because definitely this would take more time, which means more energy, to raise the same amount of temperature as liquid 1. Is that clear, everyone?
Yes, sir.
Okay. Zain, do you understand everything? Shavez, Ismail, Yusra?
Yes.
Okay, good.
Yes, sir.
Zain, have you completed your work? No. Very bad, Zain. Alright. So now, please do this as your homework. This is the similar question. And then we're going to start from this from Sunday. Okay. If you guys have any questions, please let